Welcome to day 6 of Advent of Code 2024. In today's puzzle, we have a guard that is guarding a grid or a map. Well, the grid has many empty spaces, all of them are marked as dots, and there are some obstacles like these ones. And we have a starting position for our guard, and the guard is always facing upwards like this. So these are the inputs that we have. And there are a few rules. The guard will always move in the straightforward direction. When he's facing up, he will always move up until he hits an obstacle. When he hits an obstacle, he would rotate 90 degrees to the right of his when he is facing. So when he is moving upwards, he hits the obstacle, he rotates 90 degrees to the right, so he will face to the right. Like this. This would be here, okay? So he hits an obstacle, turns right, and stay here. Then he moves straight again, which means in this direction until he hits this obstacle. And he will continue until he leaves the grid. And the good thing is that he will not end up in an endless loop. Okay, now these are the samples of the time that he is going to leave the grid. Okay? Now, we need to know how many of these empty spots he is going to visit before leaving the grid. And he might visit a spot more than once, but we only want to know the distinct positions that this guard will visit before leaving the grid or the mapped area. Okay, now in the first part, let me close this one. Again, as always, I would get the data from this file, split it by new line, and then map by splitting it to an empty string. Now I would get the rows and the columns number of the grid. So this would be useful instead of always going and calculating this value and this value. So I'm getting these three values, and this is where I get the starting position. And again, this is very simple. I will have a for loop walking through the grid for I from 0 to length to cover the rows, and this is for covering the columns. And each of the spots I would check if it's not empty, and if it's not obstacle, then it's the starting position. And I could write it like check the grid ij against this simple, but I thought we might need to go and have like the guard facing downwards or rightwards, for example. So this is to cover every direction of the guard in the starting position. Okay, pretty simple, pretty standard. So now we know where the guard is standing, and we know he's facing upwards. We know the grid, the rules, and the columns. Now for the direction. For the direction, this is very standard that we define all the direction in a array like this, and these are the displacement. So if the guard is going to move one step upwards, we are going to implement this. Subtract 1 from the x and don't change the y. If it's going to the right, then we don't change the x, we change the y. So here, if we are here, we're going to the up, we're going basically to this row. So the column number, which is this, won't change, but the row will be getting -1. Instead of having like 4 different ifs and say if we are going up and then subtract 1 from the x, if we're going down then add 1 to x, I think this is much more neater. Okay, so now we have the directions in place. Next step is to know the current direction, or basically the starting direction. The starting direction by the puzzle is always up. So we put the direction as 0, which would point to this when needed. Then we get to the interesting part, where we need to know and keep track of the visited cells as the guard passes them so that we don't count an already visited cell again. Okay, so we provide a set here, and each time the guard walks into a cell, we add that cell to the set. Now using set will automatically remove all the cells that are duplicated, so we don't need to check every time to see that if this current cell is already in the list or not. So that's why I'm using the set here. Now the most important part, or the logic. We would go into an infinite loop until we get out of the grid. First thing is that I would add the current position that I am in, or the starting position that I am in, as the visited cell, because I'm already on this cell, so I have visited this cell. Okay, so this is being added to the visited list, or visited cell, so to say. Then I would go on and find the next position that I need to go. The next position is basically simple. Looking at the directions that I am going and adding the dx and dy from that to the x and y. Okay, I think I covered this earlier, so don't need to go deeper into these two parts. This will give me what is the next x and next y, or basically next cell that I will be moving to. Then I need to check if I'm moving out of the grid or I'm still inside the grid. To find that out, we would say that is the next x is going to be less than 0, which means that are we going to step here? Are we going to step here? This way the next of x will be more than the rows. Is it this or is it this? Next is greater than or equal to rows. And we could also do the same, or actually we should do all the same for the y as well, so that if we are moving out from this direction or this direction. If we are in the next step going out, then we need to break, because we have already covered the visited cell here, so we can break here. So this is for example, suppose we are here and we are going downwards. We're here, we're going downwards, we add this as a visited cell, the next is inside grid area, so we come here, we add this as a visited, then we check the next step is here out of the grid, so we are fine. We need to break because we have already covered visiting this cell. Now, if we are not leaving the grid area, there are two options. Either the next spot is a obstacle or it's a free spot or an empty spot. If it's an obstacle like this, then we just need to turn the direction to the next direction. So if we are facing up, we need to go right. If we are right, we need to go down. If we are down, we need to go left, and if we are left, we need to go up again. So we could have it by an if, but this is, I think, much more elegant and better. Just add the 1 to it. It will always move us to the next position. But if we are, for example, here in the left, then I add 1 to it, it would become 4 because it's already 3. So when it's 4, I need to go back to 0, so I would get the remainder of that by 4. Okay, so this would do the turning for us. And then, if this is not an obstacle, we just move to that position, and that's fine. We just say that, okay, our next x and y is this one, so move to that position. And here we just go back to the while and do this whole process again and again until we finally break using this. So yeah, this is for part 1. Let's go to part 2. Now on the part 2, we need to figure out the number of the places, number of the empty places, that if we add an obstacle there, it would be an infinite loop. So for example, look at here, we are starting at this position. if we add an obstacle here, this poor guard will always end up in a endless loop. So he starts here, goes up, hits the obstacle, goes right, hits the obstacle, gets to his starting position again. There's an obstacle here. He goes up and he does this forever. We need to check all of these empty spots and see if we add an obstacle here, are we going to end up in an endless loop or not? And we of course cannot put an obstacle here because there's already an obstacle here, and we cannot put obstacle on top of the guard because he's already there. So this is the challenge that we are facing. And for example, here there is another obstacle, so that if we start here, we would do this, and then we hit here. If the obstacle was not here, we would go down, but there is an obstacle here, we added it, so we get to here and then go back and then end up in a infinite loop like this. Okay, but for resolving this, the brute force way is just find all the empty spots in the grid, add a obstacle there, and simulate the walk and see if the guard ends up in a infinite loop. This solution will check all the possible obstacle placements, which can become quite expensive, but in this example it's very simple and it's very understandable and easy to implement. So after adding one obstacle, we need to find a way also to trigger an infinite loop. Okay, that can be easily done by checking all the visited cells. So let me go to the code and then explain it more there. So here this starting position is the same as it was. It would just give us the starting position of the guard in the grid. Then again, I would split the data into grid using this, just like the part 1, and I'm getting the start position and start direction of the guard, which is always 0 because he's always facing forwards, and then start x and start y is getting from this function that we already defined in part 1. Then here we have the rows and then calls, again getting the number of the rows in a grid and the number of the columns in a grid, and set the count to 0. This is the counter that we would return at the end of the loop. Then for each of the spots in the grid, so double for loop for I and j going through the rows and columns, and then if the grid at that position is not a dot, we need to continue. So either it's a obstacle or the guard is that position. So if it's one of the two, then we need to skip that one. Otherwise, we would temporarily set this current position as an obstacle and then run an infinite loop checker. That will be done here, and if that check would give us true, then we say okay, this will end up in a infinite loop. So add 1 to the count and then reset this cell. So put it back as a dot and then go on. Now what does this function do? So again here I have the directions defined, which is basically the same as part 1, and the rows and the columns again, and these parts kind of the same thing as we had for part 1. Then I have a visited set, which is the similar set as we had in part 1, but with a very small difference. In part 1, we only keep track of the spot that the user, that the guard would walk on. But this time, a user might walk into a spot from left and exit the grid, but if he walks to that very spot from the bottom, he might end up in a infinite loop. So we need to keep track of both the position and the direction. And if he enters the same spot with the same direction more than once, then he is already in an infinite loop. So let's go to an example here. So he starts here, this position is facing up, so we say okay, this position with upwards, then he would go and do this and then comes here. He would come to this position but from the left, so we add this position with left direction so he can continue going. He would do this, do this, do this, and then comes here with the same direction. Well, basically this will trigger the infinite loop, but let's say this one. So when he gets to this with the same direction, then we would end up from the loop saying that okay, this is a endless loop. So we are adding the direction here. Now if the visited list has this state that we defined here, then we return to say okay, this is an infinite loop. Otherwise we say okay, we haven't entered into this cell from this direction, so add it to the list, to the visited cell, and the rest is kind of the same. We get the next x and y, we check if we are going out of the grid, which means that this obstacle does not provide an endless grid. We return false. Otherwise we continue as is until we either get to an infinite loop or we get out of the grid, which is here. Okay, so please go and check this code, and I hope you enjoyed the video. See you in the next one.